I'm Anil Kumar, and in this video, we will understand how concavity and derivative of a function are related. Now, in this particular video, we'll consider concave up case and see how should we, understand concave up with reference to the derivatives, right? So concave up really means that graph which is kind of like this. It could be kind of like this, like going up downwards, but it's like concave up, you see, or it could be kind of like this, right? So both these graphs are kind of concave up, you understand, or you could just combine them all, right? So these are the graphs which we say concave up. Now, what is so particular about these graphs, or what are the characteristics of these graphs? So let us say we have the function as shown here. Now, what you notice here is if I draw a tangent line at any point on this graph, then the graph is above the tangent line. Do you see that? If I draw a tangent at any point on the graph of the function, then the graph is over the tangent, right? So one thing which you notice here is that the tangent, that the graph of the function is above the tangent line, right? So that is one thing which you notice, right? What else do you notice? As far as this tangent is concerned, tangent also represents the first derivative, right? So we say tangent means first derivative. Let's say f prime x, if we have function f of x. So tangent represents the derivative of the function. So basically, we know that the function is greater than the derivative of the function, right? Most of the time. Okay. Now, as far as the tangent is concerned, if you see from left to right, what do you notice? It is always increasing. It is high negative here, less negative, kind of zero, right? Here it starts from zero, becomes positive and more positive. So if the graph is concave up, as shown here, in that case, what you find is that the tangent or the derivative of the function is always increasing. So if you are considering concave up graph, in that case, what you will notice is that the tangent is always increasing, right? So if you see from left to right, tangent is always increasing. So tangent basically means gradient is always increasing. So we are saying that gradient or rate of change, so gradient is always increasing. That really means that the second derivative is positive, right? So that means that the second derivative is positive, right? So that is what it means. So these are three major things which you need to understand when the graph of the function is concave up, right? So let's summarize these three things. So whenever you have graph of a function which is concave up, right? So when it is concave up, at that time, tangent is under the graph. The graph is over the tangent line, right? That is first thing. Second, what we notice is that f prime x, or the derivative, is increasing. And third, the second derivative is always positive. So these are the three things which you should remember. So in the next video, we will see what happens when the graph of the function is concave down. As an example, what you can take as an example is, let us say you have f of x equals to x squared, right? So if you have function f of x squared, so f prime x is 2x, right? So as x increases, derivative increases, correct? And then you also notice that the second derivative for the function is 2, which is positive, correct? So second derivative is positive. That means on the entire domain of this function f of x equals to x squared, the graph of the function should be concave up. So that's an excellent example for concave up, right? So if for concave up, you could give this as an example. The graph which I've shown here, I'm showing portion of some graph. Let us say if I say points A and B, it could be from the interval A to B, right? Or if I consider this to be my, let's say C and D, so it could be from the interval C to D, the graph is concave up. And if it is concave up, you understand what it means now, right? So the graph is above the tangent, the derivative of the function is always increasing, and the second derivative is always positive. Thank you.